The second thing we want to do with polar equation, with polar result, is figure out equations and graphs. We talked a little bit about the equations. We'll come back to that in a minute. But identify and graph polar equations by converting to rectangular. Graph polar equations using a graphing utility. Test polar equations for symmetry. Graph polar equations by plotting points. And then we'll look at some examples of that. So if we have the rectangular, if we're given minus 3, 1, so minus 3, 1, there's that point. If we're given 1, 2, 1 to the right, 2 up, there's that point. Okay. If we are plotting polar for 5 pi over 3, this is called polar graphing paper. You don't really need it, but it's nice. Here's rectangular graphing paper, here's polar graphing paper. Notice they're still on those two axes. But to graph polar, it's the polar axis. So here's the polar axis, 5 pi over 4. So 5 pi over 4 is bigger than pi. So it's halfway through here. And it's a positive number, so we're going to go in that direction to the terminal side. And here's our point for 5 pi over 4. 2 pi over 4. So from the polar axis, pi over 4 is halfway through the first quadrant, and 2 is 2 units out, and there's the point. So that's really what the last section was talking about, graphing polar coordinates. Graphing polar coordinates. But what about polar equations? Well, when we first started graphing rectangular equations, we plotted points. And when we had enough points, we could draw the graph. Well, that's one way of doing these also. Yeah. So if I have an equation, polar equation, the graph consists of all the points in the polar equation, in all the polar coordinates that satisfy the equation. So here's a couple of methods. One method, convert to rectangular. Sometimes that works well, sometimes it doesn't work well. But r equals 3. From our formulas that we have that r squared is x squared plus y squared, and r cosine theta is x, and r sine theta is y, and a tangent of theta is x over y, those 4 formulas. Right? There's no cosines or sines here, so anything we have is r. So the only way we can get it to rectangular is if I square both sides of this equation. That's one way to get there. So you square, you get r squared equals 9. And since r squared is x squared plus y squared equals 9, there's the rectangular. That's a circle centered at 0, 0 with a radius of 3. So there is the graph of r equals 3. It's a circle. R equals a constant is always a circle. R equals a constant is always a circle. Or, okay, so that was r. There was no theta in this one. Now we have no r. So this told me that r equals 3 if I was graphing it polar. I graphed it rectangular. But if I thought about graphing it polar, what that tells me is that all the distances out are 3, equal distance out. And since theta is not here, theta can be anything. So if theta is anything, theta is all the angles around. And that's why we get that circle. Here it's theta is pi over 4. That means r can be anything, positive, negative. So what I know, if I'm trying to change it to x and y, theta equals pi over 4. What I know is that the tangent of theta, right, is equal to y over x. So the tangent of theta, tangent of pi over 4, tangent of pi over 4 is 1. Tangent of theta is y over x. So y equals x, which is this line. When we think about it from a polar point of view, there's pi over 4. That distance out, there's the initials, there's the terminal side, that's opposite the terminal side. Since r can be anything, it's all the points in the direction of pi over 4, and it's all the points opposite direction of pi over 4. So one way to graph is to graph it by graphing the rectangular equation. Right? So, graphing a polar equation, graph it using x and y, or graph it using the graphing utility. Solve the equation for r equal in terms of theta. Now, just like we can't use the graphing calculator very nicely unless we had y equals a function of x. We can't use polar very nicely unless we have r is a function of theta. Right? So then you make sure you're in polar form. Okay? You're in polar form instead of rectangular form, instead of x and y. Okay? You're going to have to think about the window. And since polar, theta, once around 2 pi, okay, often we want our window to be from minus 2 pi to 2 pi in order to get there. So if we had r equals sine of theta over 2, that means r equals 2 over the sine of theta. So we put polar form, we put 2 over the sine of theta, and I would do it if you look at you're looking at your mode, and then look at what kind of things you want to graph with. Right? When you look at your graphing calculators, there's a button for window. So when you have it on, so the first thing you do is push your mode button and make sure that we are in radians to start with. Graphing doesn't work well without it. Then make sure instead of being in function mode, you're in polar mode. And then when we push this y equals button, it says r equals. So we put in r equals 2 divided by the sine of theta. And if you go to window, the best way to start graphing polar is to go into window, and in your window go from minus 2 pi to 2 pi, and that'll usually get you a pretty good picture. If it doesn't, you fix it. But there's our equation. There's our picture. There's our picture. Right? And we got a picture there of a line, right, parallel to the polar axis. And we have that. So that's how you use the graphing calculator to graph. Now, another way to graph is, instead of converting to rectangular, and instead of using the graphing calculator, we can do it by plotting points. We can graph by getting enough points and putting them on there. Right? Now, if we look at an example that will do that, right? If I had x equals 1 minus the sine of theta. So I'll make a chart, just like we did with x and y. We make a chart. You put a value for x, you got a value for y. This is solved for r. We're going to pick a value for theta. Right? And then we're going to substitute it in. So the sine of pi over 2, minus pi over 2, it's going to be minus 1. So we're going to get 2. So we go to our graph. Minus pi over 2 is down here. That's the angle. And then we go down 2. We get that point. And then minus pi over 3. Sine of pi over 3. Square root of 3 over 2. So it's minus. So it's going to be about 1.17. So we go down pi over 3. Minus pi over 3. And we go out 1.7. Not as far. And then we try minus pi over 6. Sine of minus pi over 6 is minus 1/2. 1 minus minus 1/2 gives me 3/2. So we go pi over 6, and we go out 1.5. And then 0. The sine of 0 is 0, so we have 1. So we go angle 0, we have 1. If we put in pi over 6 and pi over 3 and pi over 2, we get these values. So now, what if we were to check on symmetry, or we could do more points? You see, this function is symmetric left and right. This guy is symmetric left and right. And so if we were to look at symmetry, and here's how you figure out symmetry, right? If you were to put in, replace theta with minus theta into the function, and you get what you started with, then it's polar axis, it's symmetric this way. Top half, bottom half. If you put pi over 2 in, if you put pi minus theta into the function, and you get what you started with, then it's symmetric to pi over 2. Left and right, it's the same. And if you put in place r with minus r, and theta by theta plus pi, you get what you started with, then it's symmetric through the origin. So in this problem, if we put minus r in, we get minus r equals 1 minus sine of theta, which is r is minus 1 plus the sine of theta, not what we started with. So it's not symmetric, right? It's not symmetric to the polar axis. If we replace theta with pi minus theta, so we get 1 minus sine, place of theta, pi minus theta. Right? Sine of a difference is the sine of the first, cosine of the second, minus cosine of the first, sine of the second. Back 2 chapters back, looking at that. Right? Sine of pi is 0. The cosine of pi is minus 1. So you get 1 minus 0 cosine theta plus, so you get 1 plus sine theta, just what you started with. So it's symmetric around the polar, around the line y equals x. So since we've already got these points, graphing them, just like we did with rectangular, you connect the dots. Well then, because it's symmetric left and right, we know that that's the other half of it. And we get that picture. And we get that picture. That's how you graph polar equations. That's how you graph polar equations. Here's another one. If we have r equals 3 plus 2 cosine, if you replace theta with minus theta, right, you get what you started with. So that means it's symmetric around the polar axis, right? Around the line y pi over 2, if you plug in theta with pi minus theta, use the difference of cosines, you don't get what you started with. So it's not symmetric around pi over 2, but it is symmetric left, up and down around the polar axis. So when I go to graph this, I would want to graph it between 0 and pi. And so you put values in. 3 plus 2 cosine 0. Cosine of 0 is 1, so you get 5. So 0, 5. And continue to plot, and you'll get points that look like that. So if you connect the dots, right, and then because it's symmetric, I have the rest of it. And we've graphed the polar coordinates. So that's how you graph polar coordinates. That's how you graph polar coordinates. Right? Or, okay, so you can change it to x and y, use a graphing calculator, you can plot points, or you can recognize patterns. Just like with rectangular. If we have y equals 2x plus 5, I know it's a line. I don't have to plot points. I just have to get enough to show me where it goes. If it's y equals x squared plus 2x plus 5, I know that's a parabola opening up. If I find the vertex, and I can open it up. Well, there's some special formulas for polar. R equals a number. R equals a number is always a circle centered at 0, 0 with the radius of the number. What is going to happen every time. If you have R equals plus or minus 2a, that's going to be a number, cosine theta. That's going to be a circle. But instead of centered at 0, 0, since cosine is in the x direction, it's going to be in this direction with radius of a. Right? So it's going to be, diameter is 2a. That's where this number comes from. So from 0, 0, 2a, and there's our circle radius. Now, if it's minus, the circle's going to be on this side. Likewise, if it's r equals plus or minus 2a sine theta, sine goes up and down. So if a is positive, 2a is the diameter from 0 up. So a is the radius, and you get that circle. If it's minus, the circle's down here. A second type of important graph. Right? The second type is what we call limekins. Right? Limekins are always in the pattern a number plus or minus a number sine and cosine, or cosine. A number plus or minus a number sine cosine. A number plus or minus a number sine cosine. And if this is the result, if the numbers are equal, 3 plus 3 sine theta, 5 minus 2 cosine theta. Okay, if 5 minus 5 cosine theta, 3 plus 3 sine theta. These numbers are the same. It's what we call a cardiac, a heart. And if it's cosine plus cosine, it's going to go this direction. If it's minus cosine, this shape is going to go this way. If it's plus sine, the shape is going to go up. And if it's minus sine, the shape is going to go down. But it's this shape. There's going to be a point at 0, 0. And then if it's sine, the furthest distance out is going to be at pi over 2 or 3 pi over 2, depending if this is plus or minus. And we have that shape. If it's a plus or minus b cosine and b is smaller than a, this number is smaller than that number. B is smaller than a. Then we get this limeken without a loop. Looks something like that. Again, if it's plus cosine, it's going to go this way. If it's minus cosine, it's going to go left. If it's plus sine, it's going to go up. If it's minus sine, it's going to go down. And if you would just check in all three of these guys, 4 points. When theta is 0, when theta is pi over 2, when theta is 3 pi over 2, when theta is pi. And you will get 1, 2, 3, those 4 points, which will give me the shape of the graph. You'll get 1, 2, 3, 4, and you'll have the shape of the graph once you recognize it. And if it's a plus or minus b cosine or a plus or minus b sine theta, if a is bigger than b, a is bigger than b, then we get this shape, this limeken with a loop inside a loop. It's going to be this shape. And again, recognizing it. Another special one to recognize is what we call a rose petal or daisy petal or whatever petals. Get a picture, looks like these. If the value here is going to be A. A is going to be how long the pedal is. So it's going to be A. A is going to be how long the pedal is. If it is A sine theta, there will be no pedal on this axis. If there's a pedal on the axis, that means it's the cosine. If the number is odd, 3 theta, 7 theta, then the number of pedals will be that. See, this is 3 theta, so there are 3 pedals. If it is sine, there will be no pedal here. There may not be a pedal here, but there will be no pedal on the polar axis. If the number 2 theta, 4 theta, 8 theta, the number in here is even, then there are twice as many pedals as that number. Since it's 2 theta, there are 4 pedals. And those will get it. So if we're looking at R equals 2 cosine theta, that looks like this. 2 plus or minus 2, 2 plus or minus 2, it's the same value. Right? It's plus the sine, right? So that means it's going to be around pi over 2, up or down. And since it's positive, right, I know that this graph, without graphing the whole thing, without graphing everything, I know that this graph will look like the Cardia shape, but it'll be going up because it is positive. So you should recognize the polar equations. The graph of a Cardia. The graph of a Cardia should be able to graph it. One last picture, one last one. If it's not a shape that I know, here's that one I was just showing you, okay? I don't need to plot all these points because I have recognized it as 2 plus 2 sine theta. So the biggest that the distance could be is 4, because the biggest the sine can be is 1. So 2 plus 2 times 1. That happens at pi over 2. So at pi over 2, okay, at pi over 2, I'm right there. I also know that the sine of 3 pi over 2 is minus 1. So this would be 2 plus 2 minus 1, or 0, which is this point. And if I plot those 2 points, cosine 0, cosine minus pi, knowing that the shape is going to look like that, those 4 points are enough to give me the shape. That's graphing. That's polar coordinates. So this week, spend some time working on polar coordinates, working on these 2 sections, working on what you need to know in order to work with these polar equations, working with these polar numbers. Spend some time trying to understand it. Look at the videos.